Everyone, I'm not going to use the mic because I have gadgets and things to show you, and I use my hands. So about 2 hours ago, I almost couldn't do this talk because my computer died and it wouldn't turn back on, and I had no idea what it was doing, and there was some frantic panic and a few backup computers were set up. So if halfway through my talk we have to change computers, you now know why. Okay, so let's get started. So today we're going to be talking about USB and JavaScript. But first, for those of you who don't know me, my name is Gergana, but I usually go by Jerry because that's a little bit easier to pronounce. And you can find me on Twitter over there. And I also am lucky enough to have a weird enough name to have a .dev domain. So I have a website on there, and it's a very minimal website for now. I'm still working on it. I work for a company called BBD Software, and we make custom software. But I work for the research and development team. And a lot of people ask me what we do in the research and development team. And the plain, boring answer is we do consulting, we train the BBD developers, and of course we do some research. But that's the boring answer. We also do things like build meme generators and replace keyboards with fruit, and my personal favorite one, program astromech droids. Now, this is kind of how I started out. I don't usually settle for an app that comes with a robot. I don't like doing that. I like hacking it myself. And I find new and innovative ways of hacking my robots, usually involving JavaScript. But today, as I said, we're going to be talking about USB. Now, USB has been around for a very long time. We have a wide range of different USB devices. We have the standard USB, we have mini USB, micro USB, and these days we mostly have USB-C. And they all work based on the same standard. And they have become the de facto standard for wired peripherals. Most of the time, USB devices are plug and play, right? You plug it in, wait a couple seconds, it does some things in the background on your computer, you can use it. Most of the time. But sometimes, the dark side of the force brings us this screen. And that loading bar does not move. It just sits there. Yeah, on Mac you get the little beach ball, right? I'm not sure what the Linux version of that is, but you get that. The problem with getting this is that most of the time that device you wanted to use is actually something you were going to use only once. So it's busy installing drivers on your computer for something you're going to use once. And those drivers are just going to sit there until you eventually format your computer. Now, has anyone here ever had to integrate with USB devices? Anyone? No, a few people. What kind of languages? C++. Any others? No? Okay. Well, I've seen some Java implementations as well. Anyone tried JavaScript? No? Okay. Why not? You'll see now. I'll tell you why. Well, anyway, most of the time integrating with USB devices isn't actually that bad, because the manufacturers of the device will provide some sort of API or SDK that you use, and you connect the device and you write it into your code. It's easy to use, easy to understand this documentation. It works. The problems come when your device gets outdated. And you're suddenly sitting with the system that only works on Windows XP with IE8, and the code was written in VB6 by some developer who wrote it before you were even born. Now, this is the problem, right? Because XP is an old operating system. It's no longer actively maintained. IE8 has a wide range of security issues that they don't care to fix because they have new, better browsers to do this stuff. And the people who wrote the code are now retired, so you have to go and fix it. Okay. And honestly, let's admit it. We can all admit this. As developers, we're kind of like magpies. We really like shiny things. We like shiny new technology. We don't want to be working on that code that was written before we were born. We want to be working in the newest, latest, and greatest stuff. And lastly, and this one's actually really true, who here can say that they've worked on a system that has been running successfully in production for more than 30 years? No one, right? Because most of you aren't even 30 years old yet. So that's the thing. We can't take this newest, latest, and greatest tech and guarantee that what we write is going to run for the next 30 years. We can't give that guarantee to people. But they guaranteed it for the last 30 years. Let me give you a more concrete example. Now, I grew up on the East Strand. And I know this is a common thing, but on the East Strand, there's a very big culture of going to get takeaways on a Friday night. All kinds of takeaways, from the popular McDonald's and Burger King and KFC to your neighbor's Roadhouse. And usually these places are packed with people on a Friday night. There's queues going out the drive-thru, there's queues going out the front door, everywhere. The cashiers at these places need to work fast because there's a whole bunch of hungry people waiting to get their food. So they usually work on pretty simple systems. I mean, it's not that complicated. It just needs to be something that can take an order, receive a payment, and print a receipt. It doesn't seem complicated at first, right? So let's take this example a bit further. Say we have a Roadhouse. This Roadhouse runs on some sort of computer. Usually it's a touch screen to make it easier for the cashiers, right? And it runs on Windows. Now, it integrates with a fingerprint reader so that the cashier can go up to the machine and scan their fingerprint so they can log in quicker so they don't need a password. It has a receipt printer, so it can print out your receipt for your order. And it has some sort of credit card machine. Let's say, for the purposes of this example, that all of these things plug into the computer using USB. This is fine. We write a Windows desktop application, connect to the different APIs and SDKs provided to us by the manufacturers of the devices we're integrating with, and we make our app quick and efficient for the purpose it's meant to serve. But as we said earlier, technology changes all the time. So even the neighborhood Roadhouse needs to keep up. We now need to upgrade to Windows 10. That's fine. It's still Windows, right? And most of the devices will work if we tweak the code a little bit. It will be a little bit of a rewrite. It won't be a full rewrite. But a few years down the line, the Roadhouse owner comes to you and says, we're now moving to Android tablets because they're cheaper, they're more efficient, they're more reliable, whatever the reason is. He has a reason, he wants to move to an Android tablet. What do we do now? Well, we scrap all of the things we've ever written for Windows, and we write a brand new program from scratch. Because the way that USB standards work is that the USB devices, with the standards committee together with the manufacturers, create some sort of native SDK for that specific device. That means that there's a different SDK for every platform that we want to use. And when we move platforms, we have to write the code again. But do we have to? We have a new hope, JavaScript. So WebUSB is a proposed web platform standard. It's not on the standardization path yet, so it's really very new. It's being driven by a bunch of people from the Chrome development team. And what it enables the manufacturers of devices to do is to build cross-platform JavaScript applications so that you can connect to their devices without caring about what platform you're coming from. And now I know what you're probably thinking. Yeah, but an Android tablet and a Windows desktop are very different. Well, give me a minute and I'll prove you wrong. So it's based on the USB standards. And the way the universal serial bus works, the way it transfers data, is actually quite complicated. There's a number of good references you can go and read up about how the standards work, but it's very hardware intense. It talks a lot about very hardware specific things. So I'm going to give you the short version that you need in order to start hacking your USB devices. This is pretty much all of the code we need. Well, a few variations of this code. But let's dig into it. Firstly, you can see that it's heavily based on promises. So if you don't understand JavaScript promises, this could be a problem. But once you get your head around the promises, the rest is hardware stuff. First bit over here is the filters. So we're filtering in this case by a vendor ID, which is usually a hexadecimal number. And that hexadecimal number is assigned to a vendor, to a manufacturer of devices. We can also filter by the product ID, which is for a specific product. How do we find these numbers? Well, for the vendor and product ID, there's different ways on different operating systems. Let me show you how you do it on a Mac. So on a Mac, you click the little Apple icon, say about this Mac. And if my computer doesn't crash and it opens, no, it's there, it's there. Cool. So under the hardware section in the systems report, there's a USB. And over here, you can see all of the USB devices plugged into your computer. And if you select one of them, there's a product and a vendor ID. For Linux, there's a command line tool you can use. And for Windows, you can go into the properties of the device to find those. Once you've filtered those, now these filters aren't required. You can use them if you want to. If you don't use them, which you'll see in my demos a bit later, it just shows you all of the devices that are connected. Once you've filtered, we have to select the correct configuration for the device. A configuration for, yep?
Oh, sorry to bother you. So the vendor ID, I didn't know if you said this already, but is that like a standard, like you have to have like a standard hexadecimal? So if
it's assigned to the company.
It's assigned to the company
by the standards, USB standards committee.
Oh, okay, so
yeah.
Okay, so it'll be standard across all devices.
Yeah.
Okay.
Yeah. So all the devices from that company will always have the same vendor ID.
Okay. Cool.
Yeah.
Sorry.
So the manufacturer and the standards committee will work together to.
So every manufacturer that's out there has to come to the standard. So even the most random Chinese company out there will have to go to standard.
Yeah.
I mean, like, if you get some dodgy devices out there that people want to connect, you know.
Well, maybe not all of them have. I don't know, but.
Okay. Well, the major ones, the ones we can trust.
Yeah. So there's actually, if you have a look at the references I have on my GitHub page, which I'll share with you then, there's a list of all of the ones that people know of.
Okay.
Yeah. Yeah. So maybe some of them don't actually go to the standards committee. I'm not sure. There's probably a chance that they don't. Anyway, so we select the configuration, right? The configuration of the device has a bunch of information inside it. It has to do with how the device is powered, so whether it's self-powered or whether it needs to be plugged into the USB in order to have power. And it also says how much power the device needs, and it also has a bunch of interfaces. Most common USB devices have only one configuration, but even if they do have more than one, only one will be enabled at any one time. So an example of a USB device that has more than one configuration is your phone. And that's how your phone knows whether it's plugged in directly to the mains or into your computer, based on what configuration was selected or enabled. Then the configurations have a number of interfaces. We have to take control of an interface. An interface is a grouping of functions, or it defines a feature, a specific feature of the device. We can only control one interface at a time. That's why we claim it. When we claim a different interface, we let go of the previous one. The interfaces have a number of endpoints. And these endpoints are how we actually communicate with the device. We transfer data to the device from our computer, and we receive data back from the device. Now, you're probably wondering how we get to these numbers, 1 and 2. Well, generally, if you have the data sheet of the USB device you're using, you can find those numbers in there with what they actually do. If you don't have the data sheet, what you do is you start at 0, and then you run your code. And then it gives you an index out of range exception. And then you go to 1, and you run your code until you find the correct one, until no more errors occur. I'll show you another way you can find it, don't worry. That is just one way of finding it. Then the next bit is the transfers. So transferring of data from the device to the computer and back. It's how we communicate with the endpoints. There's a number of different endpoints on an interface, and there's different ways to transfer the data and the types of data. So if you can find the SDK for this device and reverse engineer it, you can find what kind of data the device needs to receive and send. You can also use Wireshark to sniff the packets that are being sent between your computer and the device. The only problem with Wireshark is it doesn't actually work on a Mac because Mac doesn't allow that kind of access to USB. So you'd have to use a Windows or Linux machine. There are 4 types of transfers. The first one is the control transfer. A control transfer is how we configure the device. We set it up to be able to communicate with our computer. And every control transfer goes to a default endpoint of 0, which exists on every interface. The control transfer consists of 4 parts. The first part is the request type. The request type is where we're sending this thing to. So whether it's some sort of vendor protocol or some sort of USB standard, or like in our case, we're sending it to a specific class that exists on this device. Then we have the recipient. Who on the device is going to receive our instructions? In our case, we're sending that to the interface, but it could be to the device as a whole, or it could be even more specific. It could be to the endpoint itself. And next up, what we're actually requesting the device to do. So in this case, what this number that we're sending is turning on a number of different endpoints that we're going to use for our communication. These things are set by the USB standards committee together with the manufacturer and are laid out in some sort of specification. Then we have a value, which is based on the request type. So our request type is a class, and our class is expecting a numerical value, in this case, the number 1. And lastly, we have an index. The index is based on the recipient. So you can see that our index over here is the number 2, because the interface we claimed is the number 2, and that's our recipient. The next type of transfer we have is an interrupt transfer. Interrupt transfer is for low latency data. So if you take a USB keyboard, plug it into your computer, every time you hit a key, that's an interrupt transfer. Low latency data. Then we have bulk transfers. Bulk transfers are for large amounts of data, and they allow for delays. So things like USB flash drives use bulk transfers. And last, we have a very weird word, which I learned in the preparation for this talk, isochronous transfers. Isochronous transfers are for streaming audio and video. And they don't guarantee data delivery, but they do guarantee the amount of time that they're going to deliver the data in, because they reserve bandwidth on the USB bus. So let's go for the demo. Hopefully the demo will not end up like that. But before we get to the actual demo, I want to talk about what we're going to be using. So we're going to be using an Arduino Leonardo board. The reason we're using a Leonardo board and not just any Arduino board is because there's only a certain set of Arduino boards that actually allow full control of the USB port. and Leonardo is one of them. The Arduino Uno doesn't, for example. And I know what you're thinking, but we can program the Arduino board already with the Arduino IDE in C and C++, and we even have a JavaScript library called Johnny 5 for programming Arduino boards. And yes, we can. And yes, we actually do still need this code. So there is still C code running on that Arduino that I've already put on there. Because we're not writing with WebUSB, we're not writing the code that controls the Arduino board. We're writing something external to control it externally. So there's still some stuff running on there, and the same way that we would connect to some device over Wi-Fi or Bluetooth, in this case we're connecting to it over USB and changing things in the way it gets controlled. And I'll explain a bit more about that later. The first thing we're going to do is we're going to blink an LED. Now, why are we just blinking an LED? Well, when you start learning a new programming language, the first thing you do is you write hello world. When you play with electronics, the first thing you do is you blink an LED. So blinking an LED is the hello world of electronics. So that's why we're going to blink an LED. Now, this is kind of what our setup looks like. I know it's very simple. We've plugged the LED right into the board. Now, don't try this at home. This setup is not recommended. You should use Ohm's law to work out the amount of resistance you need and put a resistor in there. The reason it works is because these development boards, the Arduinos, Raspberry Pis, all of them, they actually have some built-in resistance. So that's why it's not actually going to blow the LED. But every now and then, the built-in resistance on these boards can fail, and then the blue smoke inside the electronic component leaves the component, and it doesn't work anymore. And you think there's something wrong with your code, because the first thing you think is, there's something wrong with my code. It's not. It's just because the component is broken. And over there, I have a bunch of backup LEDs in case something goes wrong. Another important bit here is the pin that we're connecting to. So remember, we're connecting our LED to pin number 13. That's going to be important for later. So let's get to some code. Over here, we have a website, which consists of 3 files. Firstly, the styles, which I'm not really going to talk about because it's just trying to make the website look like something. Then we have an index HTML and an index.js. They're both empty. Let's add some code to them. I knew there was something I forgot over there. All right, first thing we're going to do is add some HTML. This HTML imports the style sheet, imports the JavaScript, and it has 2 buttons, a connect and disconnect button. Now, let's save that. No, damn it. My Command S doesn't work anymore. Anyone had that problem before? All right, let's write some JavaScript. First thing we're going to do is get those 2 buttons. The connect button and the disconnect button. Once we have those buttons, we're going to define a device. This is the USB device we're going to use throughout the code. We're defining it on a global scope so we can reuse it everywhere. Then, when we click the connect button, we're going to connect. And what this code does, it should look very familiar. It's the code we just talked about in the slides. The vendor ID here is the vendor ID for Arduino. And you can see we're selecting that configuration interface. And then at the bottom here, we're just hiding the connect button when we're connected and then showing the disconnect button. Let's also disconnect. So when we click the disconnect button, we're going to disconnect. On disconnect, it looks very similar. The only difference is that now we're sending the value of 0 in the control transfer to tell that class that we will no longer be using it, and then calling device.close. Let's save that. Now, something interesting is going to happen when I plug in this Arduino in my USB port. There's going to be a pop-up. And that is because, as I said earlier, there's already code running on that Arduino. And it's using a WebUSB library to find the browser on my computer that is open and force it to send me a notification to tell it that the Arduino is ready for my new website to use. There's that pop-up. And you can see it's localhost 8080. And if we go to it, it's not actually connected yet because we haven't started up our website. To start it up, I'm just going to use something called HTTP server to just serve that HTML page. Now, if we refresh here, we have our page that we wrote. And we can connect to the Arduino. You see, as soon as I click connect, it lists all of the Arduino devices connected to my computer. We can connect there. As soon as I click connect, it shows that over there. I know it's really small, but it's a little USB symbol. The reason for that is if there's any website that has connected to one of your USB devices and you're on a different tab in your Chrome, you can see that there's something wrong there. And you'll know that it shouldn't be connected to something on your USB. If we hit disconnect, it goes away. One other thing I wanted to show you is if we add a console.log over here, and we log the device. Now, if we connect again, it should log that device as soon as we connect to it. And if we go to the console, you can see the USB device has been logged. And this is another way you can figure out what configurations and endpoints to connect to, so you don't have to go from zero. Just log it the first time. And configurations, interfaces, and endpoints can all be found inside here. OK. I'm going to put that over there and disconnect. So let's make that LED blink, right? Let's add some more HTML. And then in our JavaScript, first thing we're going to do is get the connected div so we can show and hide it based on whether we're connected or not. Then we're going to get the on-off button. And then we're going to get the pin number input box. Once we have that, let's show the connected div when we connect by calling and changing its display to block, and hide it when we disconnect. Whoa. That one, by changing its display to none. Now, in order to send data between our computer and the device, we need to do it using unsigned integer arrays in JavaScript. So let's define a data array. Of size 3. This is the amount of data we're going to be sending. Now, when we click the on-off button, we're going to send some data. What the send data does is it does some error checking with a very fancy alert to warn us that we haven't filled in the pin number. Sets the first element in the array to our pin number, and the second element in our array to either 0 to turn the LED off or 255 to turn it on. And then we call device.transferOut to endpoint number 4, and we send that data. If we save this, we should now have a website with a blinking LED. Let's refresh this and connect to our Arduino again. Pin number was? I was checking who was paying attention there. Not many people. And blinking LEDs. Hello world. Okay, so let's write a bit more than hello world. Next thing we're going to write is for this little servo motor over here. Now, the servo motor has a lightsaber attached to it because I needed a way for the people at the back to be able to see that it's actually working. So I just attached a cardboard lightsaber to it. So all we're going to do is make the lightsaber wave. First, we're going to add a button called wave button to our HTML. We're going to get that button in our JavaScript, the one called wave button. And then over here underneath the other send, when the wave button gets clicked, we're going to send wave. So we'll use that last element in our data array so that our LED can still work to send either a 0 or a 1 to turn waving on or off. Let's save that and refresh over here. Once we connect, let's make sure that our LED is still working. Okay, that's good. And okay, cool. So that's it for my Arduino demos. Oopsie. That's good that that was it for my Arduino demos. And I have one more demo for you with this device over here. I got this from one of the teams at work. They've been using it for a very long time for a number of their systems. It's a fingerprint reader. It's a USB fingerprint reader, to be more specific. And the problem with this device is that it only has an SDK for Windows 7. So there is no way to upgrade it or move operating systems. So if you remember, we were talking about it earlier, right? When the Android tablet comes, what do we do? Well, this is where WebUSB comes into play. Now, I'm not going to show you too much of the code. Well, let me show you some of the code for this. I did not realize how complicated fingerprint readers were. So this is the code for the fingerprint reader. It's about 160 lines of code. Not too bad, right? I mean, and all it's actually doing, if you have a look at some of it, it's a lot of transferring of data to the device and then waiting for the device to respond. It's about setting up the device. That's the part that actually takes the most amount of code. It's stuff like sending some sort of command to tell it to turn on and then waiting for it to respond to say that it has done it. Things like that. And the part where it generates the image of your finger after it's read it takes 192 reads from the fingerprint reader to the computer. So because it can only send small amounts of data over USB to guarantee the delivery of the data. Anyway, let me show you it working. I have it deployed here to Firebase. I'm going to plug it in. And then click connect. So you see on this one, I don't have a filter, so it shows me everything, including it thinks that like my camera is a USB device. I'm not sure on that part. But that's the fingerprint reader over there. So once we connect to it, it says it's ready. So we can click scan. And you see the little light turned on the fingerprint reader. So if I put my finger on it, creates a fingerprint. Now that's really cool, but I want to show you something even cooler. Now this over here is my phone. No, that's not my phone. That's Christoph's phone. This is my phone. And that is my phone. Now, I'm going to go to that very same website that we were just on. Zoom in a little bit. And plug this fingerprint reader into my phone. I'm going to hit connect. It's going to pop up with the only USB device connected to my phone. It's going to prompt me. So this is an extra Android security feature prompting you. Are you sure you want to allow this website to access this device? I'm going to say OK. I'm going to push scan. Blue light turns on again. Exact same code, exact same website, working this exact same way on a Mac and on an Android phone. If that's not cool, I don't know. I can't impress you guys. But now, I know you may be thinking, this does not seem safe. Why can websites access my USB devices? And if you're not thinking that, you should be. And look, it's still a very new feature. They're still working on it. But they are putting in some contingencies to make sure that it will be secure. Firstly, it's HTTPS only, which means that at least our data is encrypted. It cannot run on a non-HTTPS website. Then it requires a user interaction in order to start scanning for devices. So we have to click a button or some sort of action is required from us in order for it to scan. It's not like you can go to a website and suddenly it's connected to all your USB things. It also requires permission. You saw on Android. Chrome on Mac doesn't make it as clear that you're giving permission to the device, but the Android one makes it pretty clear. Are you sure you want to give this thing permission? And you can also control it with a feature policy. A feature policy is a mechanism that allows developers to selectively enable and disable certain browser features and APIs so that you can control whether those things are accessible. And there is a specific header, HTTP header, that you can provide to disable WebUSB. And lastly, human interface devices like keyboards and mouses are not allowed. That claim interface method that we were calling, it fails because their interfaces are protected. I was actually a little bit worried when I read this part because I thought fingerprint scanners were human interface devices, but apparently they're not, or at least this one isn't. But what that means is that there can't be a website that could somehow create a keylogger for your USB keyboard.
So does that only apply to keyboards and mouses and webcams?
Webcams as well, yeah.
Not yet.
Not yet, yes. So yeah, you can't access human interface devices yet. New feature. Then the support. Support is a bit more worrying. So as we saw, it's supported in Chrome. It's driven by people who work on Chrome. So that's why it's supported in Chrome. And not that anyone really cares, but it's also supported in Opera. The Edge one is actually a lot closer to the yes, because Edge is going to be based off Chromium very soon. It's already in beta. And as soon as it's based off Chromium, it supports WebUSB. Firefox is undecided, undecided, because they don't usually support things that aren't on the standardization path, and this hasn't been put on the standardization path yet, so they can't make up their minds. And sadly, Safari has said no, which means no iOS support, at least for now. So Safari and Apple have a big thing against giving hardware features to the web, because then it moves away from their actual apps. But yeah, it's a big thing, and people are fighting them because people believe it's necessary, but we'll see what happens. That's it. Thank you. Any questions?